Day 62 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. You know how we do. I hope you guys are excited. I hope you guys aren't feeling burnt out. And I hope you guys are staying motivated, guys, because we have a long way to go. We are nowhere near being done. But before we get started, guys, don't forget, bring a mouse over here for me, guys, and click that subscribe button for me. Then after you click that subscribe button, go ahead and hit the like button for me, guys. Then after you hit that like button for me, guys, go ahead and drop a bank emoji in the comments. I need all of my bankers out there to go ahead and drop that bank emoji in the comments so we can run this engagement up and bring more awareness to the Swift community as a whole and help build this Swift community up, guys. Now, with that being said, guys, the main event, the part you've all been waiting for, the question. Today we have question number 994, rotten oranges. The difficulty level is medium, but you guys already know how we do. We're not going to let that deter us. We're still going to keep the solution as simple and easy to understand so we all can learn and we all can understand what we're learning, and we're just not typing without knowing what it is that we're typing. So let's see what it is that the question is asking exactly. It says, you are given an m times n grid where each cell can have one of the three values. 0 represents an empty cell, 1 representing a fresh, or 2 representing a rotten orange. 1 representing a fresh orange, or 2 representing a rotten orange. Every minute any fresh oranges that is 4 directionally adjacent to a rotten orange becomes rotten. Return the minimum number, return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. So let's break that down and see what they mean. First, they give us an input, the grid. The grid is equal to an array, 2D array. We have an array inside the array, each representing a different row. The output is 4. So let's see how they got that first. So they say a 2 represents a rotten orange. So remember, guys, this is the first row, this is the second row, and this is the third row right here. So in the first row, well, the input that we're starting, the 2 represents the rotten orange. We want to know how many minutes it takes until all of the oranges are rotten. And it only goes 4 directionally adjacent, meaning it goes up or down or up, or left or right. These diagonals do not matter. So first we have 2, 1, 1, and that represents this row. So this orange is rotten. The 2 is the rotten orange. This is the 2, this is the rotten orange. Then we have the 1, fresh orange. Then we have another one, that's the fresh orange. And we do that for each row. So this is the second row. We have 1 fresh orange right there, and we have another fresh orange right there. Then we come to the third row, no orange right there, so that's 0. Then we come over to the right. We have 1 fresh orange, that's that one. We have another fresh orange, that's that one right there. And we want to know how many minutes it will take for all of the oranges to be rotten. So if you look, this is how we start. This is minute 0 right here. Boom. So minute 0, this is what we're working with. Then we come over and we notice oranges, the adjacent orange is turning rotten, right? So boom. That means this 2 is going to turn this orange rotten right here, and it's going to turn this orange rotten, right? So first we have 2. We come over. Now we have this orange rotten because it's right next to it. And then we have this orange is rotten. This orange right here is rotten too because it's right under it, right? So then we're coming over. That's the first minute. Then we're doing the second minute. So these 2 oranges, those 2 oranges are already rotten. So then we come over. This orange is already rotten. But now, since it's next adjacent, this orange becomes rotten. So now all 3 of these are rotten, and that's in minute 2. Then we come over here. This orange is already rotten because it was beneath the original rotten orange. But now this orange is next to this orange, right? But a minute has passed, so now this orange is rotten too. Then we come over here and we check these oranges. Then this orange becomes rotten right here because is underneath this orange, right? It's underneath this orange, so this orange becomes rotten. Then we have 1 more minute for the last orange right here to become rotten right here, and now that orange is rotten, and that took all together 4 minutes, and that's what we're trying to figure out. So let's look at example 2 just because there's no pictures, so we could break it down. First, we're starting with this orange. It's rotten, right? There's no orange under that one, so that one's not going to become rotten. But there is one that is next to it, right? So this orange becomes rotten. So then we come down, and this orange is rotten. Now this orange is rotten. This orange is under that orange, so that orange is going to become rotten. Then we're going to look at this orange. This orange is going to become rotten too. But if you notice, we skipped this orange because this orange is in the bottom left. This orange, if they were underneath each other, it'd be easier to see, but this orange is all the way in the bottom left, so there's nothing adjacent to it, or four directionally adjacent. There's only an orange diagonal to it, but this orange never gets touched by a rotten orange, which means all the oranges will never be rotten because this orange is not adjacent to any rotten oranges because it's in the bottom left corner, and that's why the output is -1, and the explanation is the orange in the bottom left corner, row 2, column 0, is never rotten because rotten only happens 4 directionally, meaning it cannot go diagonally. It only goes up or down, or left or right, which would leave this orange in the corner, in the bottom left corner, not adjacent to any rotten oranges, which means it would never rot. So we will return -1. And then grid 0, the output is 0 just because there's only one orange and it's not adjacent to anything. So it's only one rotten orange, so that's just gonna be 0 since there are already no fresh oranges at minute 0. The answer is 0. So I hope that makes sense to you guys. Go over it again if you need to. But just remember, these equal each row. These represent each row. So that's row 1, or row 0, I should say. And this is row 1, and this is row 2. So just remember that as you're coding. So let's see how we're going to get to the code. Now, luckily, guys, you know how we do. We're going to keep this code as easy and simple to understand as possible. And the first thing we're going to do is we're going to declare a variable called curve grid, and we are going to set that equal to grid, right? Excuse me, guys. Then we're going to come down here and we're going to say let rows equal grid dot count. Then we're going to come down here and say let columns, or we're going to say calls for columns equal grid index 0 dot count. So this is going to represent the rows and the columns. Then we're going to come down here and declare a variable called minutes. We're going to set that called min, and we are going to set that equal to -1. Then we're going to come down here and we're going to declare another variable called fresh. We're going to set that equal to 0. Declare another variable called current rotten, and we're going to set that equal to 0. Excuse me. Oh, man, guys, I'm sorry. Then we're going to come down here, declare another variable called Q, and this is going to be equal to an array of a tuple, and it's going to be, you're going to open up the array brackets, then you're going to open up the parentheses inside of the array brackets, and you're going to put int, comma, int. Then you're going to come out here, and we have to initialize it, guys. So that's what we're going to do. Then we're going to come over here, and we're going to say for I and 0 up to rows. Then we're going to come down here and we're going to say for j and 0 up to columns or calls. Then we're going to come down here, we're going to say if grid index I index j is equal to 1, then we are going to increment the fresh count by 1 by saying fresh plus equals 1. Because remember, the 1 is the fresh oranges. Then we're going to come right here and we are going to say else if grid I index I do the same thing, index j is equal to 2, Then we are going to come down here and we're going to say Q dot append, open up the parentheses twice, guys, and we're going to say I and J, and that's going to keep track of the rotten oranges that we have. Then we're going to come down here and we're going to say if Q dot is empty, comma, fresh is equal to 0, we're going to say return 0. Then we're going to come underneath that and we are going to say while exclamation point Q dot is empty, meaning Q is not empty. That's what the exclamation point does. We're going to say for underscore and 0 up to Q dot count. Then we're going to declare a variable called, it's going to be a tuple, and it's going to be cur row, comma, cur call. Then we're going to come over here and we're going to say equal to Q dot remove first. Then we're going to come over underneath that, declare another variable called neighbors. We'll set that equal to, we're going to open up our array brackets. Then we're going to come and open up some parentheses. We're going to say 0, comma 1. Then we're going to put a comma outside of that, and we're going to come over, open up some more parentheses. We're going to say 1, comma 0. Then we're going to open up some more parentheses, and we are going to say -1, comma 0. Then we're going to open up some more parentheses, and we're going to say 0, comma -1. Then we're going to come underneath that and we're going to say for dr, or excuse me guys, open up the parentheses for dr, comma dc. Then we're going to say in neighbors. We're going to come down here and we're going to say let new row equal cur row plus dr. Then we're going to do the same thing for the columns. We're going to say new call equals cur call plus dc. Then we're going to come down here and we are going to say if new row is greater than or equal to 0 and new row is less than rows, and new call is greater than or equal to 0, and new call is less than calls. Hold on, let me see how I initialize it. Okay, so yeah, calls with, and we're not done yet, and cur grid. Then open up the array bracket, say new row. Come outside of that, open up some more array brackets with the new call. And then we're going to come over here and say it's equal to 1. Then open up some brackets. Then we are going to say Q dot append, open up some parentheses twice, and we're going to say new row comma new call. Then we're going to come underneath that and we are going to say cur grid, and we're going to open up some array brackets and we're going to say new row, come outside of that, open up some more array brackets and say new call. Then we're going to say equals 2. Should be a 2. And after that, and come underneath that and we're going to say fresh minus equals 1, because the fresh is turning into a rotten. Then we're going to come down here and we are going to say min plus equals 1. That's going to increment the minutes. Then we're going to come down here and we're going to say return fresh equals 0. And if that's not true, then we are going to say min colon -1. So let's run this, guys, see how it goes. Fingers crossed, fingers crossed. And of course, we have a typo. Let's see where the typo is. It says error expected after if condition. So hold on, let me see, guys. Let's see what we did wrong up here. Let me see, guys. So that should be, sorry about this, guys. Sorry about this. So we're gonna say, oh, here it is. Gotta be equal white space, guys, on each side of the equals or greater than or less than sign. And there it is, guys. Boom. You know, those bugs always make me nervous, man. You never know. So let's submit it and see how it runs. Boom. 6 milliseconds beats 78.53% of users with Swift, guys. That's what I'm talking about. I hope you guys learned something today. This is a very easy to understand solution, I think, and I hope you guys think so too. Get one more good look at it so you can get it, read it, learn it, love it, guys. And until next time, I'll see you then for another day, another LeetCode problem. Peace.